Welcome back, guys. So we went through creating an instance and now we need to connect to it, and we will see how to connect from Windows using PuTTY because Windows does not understand the .pem file. So we will use a SSH client that will use this PuTTY. We will use an SSH client that will load the PEM file and convert it into a PuTTY private key, and we will use that key to connect to our instance. Now this is all Windows. What happens when you come to Linux? So in Linux they say that your key must not be publicly viewable for SSH to work. Use this command if needed. And this is the command that we have to run. But what does this stand for? So in this video, we are going to understand what this command means. So when you create any user, let me save this as something. So when you create any user, what happens is, actually let me save it as vishu.sh because it's a bash script. So when you create an user, suppose I create a user Vishu. So in Linux, there's an username, and the username is also part of a group. This group can have many members in it. And why does we have it like that? So suppose you have a school and you have teachers and you have students. If you create individual permissions for each one of them, there would be as many permissions for every teacher and as many permissions for every student that is present in the school. But if you create two groups and you can assign all the teachers to the teacher group and give one permission, and you can assign all the students to a student group and you can assign one permission to the group, and it would go to all the students and teachers. So all the teachers would have right access to question papers and all the students would have read access to question papers. So instead of giving out permissions individually, we create a group, assign the users in a group, and then give them permissions to do stuff. Now coming back over here, whenever you create an user in Linux, it is going to create a new group with the user name and assign that user to that group. When I create Vishu, it will also create a group named Vishu and add Vishu to the group. This would be the primary group. And then I can append Vishu to any other groups that I want. We added EC2 user, which had a primary group of EC2 user, and we added it to a group called Apache. So this is the secondary group. Now users and groups are clear. Coming back to permissions, Linux works on three common permissions that you will always see. One is read, the second is write, the third is execute. Now usually when you see any permission, it would be something like D, RWX, RWX, RWX. What this means, let me pull up an example right now. I can take this, go to PuTTY, load my lamp, put the public DNS, and if I do an LL over here, actually let me do var www html. We will take this example. I'm going to copy all of this. When you select anything in PuTTY window, it copies it. So I will paste it over here. Now it's very important to understand what this stands for. So the first thing I want you to know is this is the user and this is the group. Permissions are always like here there are perms, and then here there's the user and user who owns it, and then next is the group over here. We need to understand what this stands for. So I already told you there's read, write, and execute. So R is read, write is W, and execute is X. So we know RWX stands for. So this first three RWX will always be the user. The next three RWX is going to be the group. And the last RWX is going to be other. So what does other stand for? It means that everyone else who is not the user or the group, anyone who does not belong in that group. Suppose you have accountants who are neither teachers or students. So they won't have access to the question paper. However, teachers would have read-write access to question paper. Students will only have read access to question paper. They can't write inside the question paper. They can't change the questions. So there are other people except the user and the group. And the third octet, the third section is for others. So let me break this down. So we'll come back here and I will make this as read. So this would be user, this would be group, and this would be others. So here we have RWX, which means the user can read, write, execute. Group can also read, write, and execute. Others can also read, write, and execute. So we have this RWX. Why is it telling to do 400? So chmod is used to change permission. And what are permissions? These are the permissions. So we use chmod to change this. Now this is RWX. So what does 400 stand for? So again, permissions will always be user, group, and other that we have. So if we break 400, what would it be? So this would be 4, this would be 0, this would be 0. So we can break this down like this. Now what does 4 stand for? Is RWX 4? No. Each of this character has a value in Linux. So read has a value of 4, write has a value of 2, and execute has a value 1. So when you're saying 400, the user's value is 4. What is the user's value when it comes to 4? The read value. So we don't need write or execute because 4 is satisfied right over here. So this would turn into like this. So R hyphen hyphen means do not write or do not execute. So what condition would satisfy 0? None of this. So this would be hyphen hyphen and hyphen, which means none of them can read, write, execute. Same goes for other. So when we have a permission like this, what this means is it's 4 plus 2 plus 1. That's 7. So RWX is nothing but over here it's 7, and the next one is also 7, and the last one is also 7. So when I come back to my instance, I can do a touch Vishu and do an LL, and it would create like this. Now let's break this down. So this is 4 plus 2. So let me break it down as user, group, and others. So first one, remove this. The first one is RW minus, which is 4 plus 2, that is 6. Then come back here, this is also a 6 and this is 4. So the permission for this is 664. So now what I can do is I will do chmod 400 Vishu because I just created this. Now if I do an LL, you will see that there's only R and nothing else. And let me break this down again. We will ignore the first one, make it into 3 sections, and over here you can see what happened. This is the same permission that we got over here. There's R equal to 4 and everything else is 0. So what we do is when we run chmod 400, what we are doing is we are saying only the user, which is EC2 user, should be able to read the file, not even write into it, just read it. So its only purpose is to connect to the instance. We should not change it because the instance would not accept a key that it doesn't know. So when Amazon launches the instance, it creates a public and a private key. So this public and private key are generated when the instance is launched. So this both keys, the public key is available for everyone, the private key is only available to you. The public key is there, and if you have the private key, you can log in. These two are together. So when you change the private key, these two doesn't match, and that's when the instance would not let you log in. So it says that users should only be able to read it. Other people in your group cannot read it, so they cannot use it to SSH into your instance, and everyone else also cannot read it. So I hope this helped. This is very fundamental when it comes to Linux or cloud. You will see permissions everywhere. And the last command is ssh-i. I will just go through this real quick. The SSH command is used to connect to any other machine remotely outside your host machine. -i will tell where the key is. Then we put the name of the key, and this is the username at the public DNS. You can use EC2 user at this IP, public IP, that should also work. But that is it for this video, and I will show you how to connect using a Linux instance. You can do similar thing on your Mac if you have a Mac. So I'll see you guys in the next video.